Calculator. Go. Okay. Sheet. My shoe fell off.
Yeah. Yep.
Hey, I did one of these.
Is there the total of the
Oh, wait a minute.
Okay, so together will cost
All three.
You could, you don't have to. You got them all? Okay. So tell me your process. How'd you figure this out? Okay. 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 So you're saying these two are the same price? Okay. But if you took, so you took this minus the $4.99, and then you divided by 2. Okay. Okay. That's all right.
Okay, so these two together equals $4.
Did you get it? Okay. Oh, okay. Okay, so it's kind of like a Sudoku. Okay. Okay. This is what I would like you guys to do. So I would like somebody to explain their thought process as to how they solved this. Where did you start and what did your group do? Who wants to share that? Nobody wants to share what they did? That's okay, you don't have to be done. At least tell me where you started. Okay, now a lot of people want to. Yeah, where you started. I don't care who.
What I did was I subtracted, actually divided what they...
You're okay, there we go.
What I did is I divided the amount
Okay,
of
you guys should be checking the speaker first off.
3
I know you're
cupcakes
super
by,
extra
sorry.
No, you're okay.
I divided the amount of 3 cupcakes, what that equals, by 3 to find what 1 cupcake equals, and subtracted that from what a donut, ice cream, and cupcake equals, which then I found what ice cream and donut equals, and then I subtracted that from what a donut plus ice cream equals to find what ice cream equals, and then subtracted the donut, ice cream from donut, and then I got all of them.
So you guys kind of, so Ethan and Aiden kind of had the same thought process. You jumped around almost like a Sudoku, right? But what was the first thing you guys all went to? What was the first thing? Okay, why did you go to the cupcakes? Because there was 3 in a row. So if I were to ask you to represent a function that showed 3 cupcakes, how could you represent a function if you were to write that as an equation? So 3x equals $14.97. So we all started there. So you may not have thought that you used an equation, but we all used an equation. Okay? So you divided this by 3, and what'd you end up with? Okay? So $4.99. From there, it kind of depended how you went. So my original plan was not to give you one this difficult, so that way you could go back and look at this. Well, no, it wouldn't have mattered. That doesn't matter. But what I do want you guys to notice is that you can use these equations, which is exactly why we're going into systems, to get there. So if you know that this is 3x, and I say x represents cupcakes, how else could I write an equation? Which one? What'd you say?
If it's the ice cream plus the donut plus x equals
This one? Okay, so what would that equation be?
x plus ice cream.
Okay, so if I say x equals cupcake, could I say y and z equals something else? Okay, what could y equal? What could z equal? Okay, so how many unknowns do I currently have? 3. Okay, so that's why we're moving, because you guys are used to solving unknowns with 1. We've never solved with 2, but now I'm going to ask you to solve something with 3 unknowns. Okay, that's where our system all comes into place. So that's what we're going to work with. How many of you got $2.99 for the ice cream? A lot of you guys? Good. Okay, and then how many of you got $1.19 for the donuts? Good. Okay, so again, this is why I said this in the beginning. If you like puzzles, I'm going to borrow your table. You're going to really like systems, because that's what it is it's a puzzle. If you do not like puzzles, we're going to learn to like puzzles, because we have to like puzzles. Okay? So by the end of this, so this is going to stay up. However you solved it today is totally fine. But by the end of these next 3 days, you're going to have 3 different methods that you can solve using this. So that way you guys will be able to choose that. Okay, so that's what we're working with. The next thing I did for you guys is I wanted to make sure you guys had notes for your in your notebooks that were going to stay there, okay, which is why I had you grab all of those pieces of paper. So this is what I'm going to have you do, and I'm going to have you put it in this order so that way you don't mess it up. So the first thing you guys need is this piece of paper. And I'm actually going to have you write on them before I have you glue them in, because I think it'll be easier for you. This one. Sorry. Okay, so your objective today is that you guys are going to graph a system of equations. So I guess I lied to you guys. The first paper you actually need is this one that says systems of equations, and it gives you the types of solutions. So you have to know your types of solutions before we can graph them. Okay, so I want you to use what you know based on what we've done with previous equations, and I want you to talk to your table mates and see if you can come up with a way, or how many solutions you think these would be. So these types of solutions, what you think we would call these based on words we've used with our previous equations. So for example, like null set, infinite solution, those kind of vocabulary words. Okay? So do that first. Do you need that?
This is probably
Thank you.
did you understand? Better? Feeling better?
Well, this is not no
Okay, so looking at your first graph, what does that look like? How many solutions do you think that that's going to have? 3? Why do we say 3? Because it's a graph of 3? Okay. What did you say? You can do as many lines as you would like. I just want to know how many solutions would fit both of these lines at the same time. Okay, so now I'm hearing 1. Why do you say 1? In math, there's only one solution. Okay. Does anybody else want to add on to that? They intersect at one point only. Okay, so the first one, that is the most common type of graph that you will deal with. So for the first one, you do need to write that that is one solution. And just like Tage said, they do intersect at one point. Okay, so it's one solution, they only intersect at one point. Meaning it doesn't matter how many graphs I look at. So if I look back there, that would be a perfect example. Each one of those things can only cost one thing, and I can only buy so many of them to get my total. So that's where it can only be one solution, it can't be multiple. Okay, so what about the second graph? It's what? Why is it null? Because it doesn't have any points. Okay, what else can we say about the graph? It'll never intersect because it's parallel. Okay, so that second one is a no solution. They are parallel lines. And then what do you think that means about the slope? Because really the slope is going to tell us all of this stuff. It's what? They have an equal slope. Why do you say equal? Yeah, they're both going the same direction. They never intersect. Okay, so that should be a really big clue that if you get something that has the same slope, what is that going to tell you right away about that problem? There's going to be no solution. Okay, so parallel lines, they're going to have the same slope. Okay, and then what about the last one? Okay, why do you say infinite? There is one line, yes. So it could, it's going to be the exact same line. Typically when you see this, you're going to see it in a standard form. And then when we solve for that y to put it back into slope-intercept form, they end up being the exact same line. It'll probably never happen if I give you two slope-intercept forms, because it's really easy to tell them that it's the same line. So that one is infinite. And you can put the same line. And it has to be in that y equals mx plus b form. It can't be, it can be the same line, but in order to graph, can we graph a standard form line? Very easily, just by graphing. If I said, hey, here's this equation, and ax plus by equals c, throw it on a graph. Can you throw it on a graph without doing any work to it? No. Okay, so you have to have it in slope-intercept form. So I am going to give you some practice